Welcome to Komputerpedia channel, where we learn computer science, here using English and Bahasa Indonesia. Today, we're going to talk about databases. This is a set of videos, consists of 10 videos, and this is the first one. In this video, we're going to talk about entity relationship. So, we're going to talk about entity set, attribute, and relationship. So, let's go. First thing first, what is an entity set? Entity set is an object that exists in the real world that is different from other objects. It has attributes and as the builder of the whole system. For example, we have an entity, a man who works in a company. That's an entity. Me, who work at Universitas Gadjah Mada as a lecturer, that is an entity. Each entity has an attribute value, and the kinds of attributes is vary among the entities. For example, here, the man who works in the company, he have 90 numbers of 000, 11, 3, 4, 5, 2. That's the ID of that particular man. For me, I have an IP, the ID of my worker ID. That's quite long, which is quite long. So that ID is just for me. That's my attribute. And in addition, a worker also has the date of birth, maybe place of birth, and things like that. Here, the birth date is an attribute of a worker's that's parallel to the ID numbers of worker. So each entity, they may have more than one attribute, and they are parallel and not connected. That's an entity. So this is just like a real world object, and by combining this entity into a set, we are building a whole system of databases. So that is an entity set. There are 5 types of attributes that we are going to talk about here in this video. The first one is simple attribute, which is just a simple value. It cannot be decomposed into more specific attribute. For example, ages. We only have one ages, but maybe it can change. Along the year, it will change. That's the simple attributes. Maybe another example is gender, whether we're male or female, and that's it. That's the simple attribute. The second one is a composite attribute. A composite attribute is, it can be, the attribute itself, it can be divided into smaller attributes. For example, name. Usually in Indonesia, we have like a minimum of 3 words length, 3 words name, and it can be divided into 3 types: first name, middle name, and last name. That's the very common practice in Indonesia. Well, there is some with 2, some with 1, maybe 4 or even 5. That's how diverse it is in Indonesia. But usually in another country, we just can divide it into 2, which is the first name and the last name. That's the standard of like the world. When you're on your passport, it says the first name and the last name, not the middle name. So that is a composite attribute, an attribute that consists like a few smaller attributes. Names can be divided, consists of the first name, middle name, and last name. That's the first example of the composite attribute. Next, we are going to talk about the single valued attribute. This single valued attribute is an entity whose attribute can only contain one value. For example, this is the worker's ID number. Its entity can only consist of one ID number. And one ID number, well, will always stick to 1%. Another example of single value is a simple attribute of gender. Each person can only have one gender, male or female, and that's it. That's the example of the single value attribute. The fourth one is the multi-valued attribute. So this attribute can contain 0, 1, or more than one value. For example, telephone number. Nowadays, here in Indonesia, maybe along the world, like it's very common for us to have two mobile phones with two different number. One is for a primary number and one is for the internet. So this attribute can be more than one, or even none. Maybe for the telephone number, some people, they didn't have any phone, they didn't have any mobile phone. That's fine. That's the fourth attribute types. And the fifth one is the derivative attributes. For example, ages. If we have the date of birth and the current date, and then we can get the age. That's derivative. So if we build a system and the system does not ask the age but asks the date of birth instead, we still can get the age of that person by using derivative calculation, not the one that's complicated in calculus, but a simple derivative one by reducing the current date and the date of birth, and then we can get the age. So that is the fifth attributes of this slide, this video we're going to talk about. Next, we are going to talk about relationship. The relationship explains the relationship between entities. So the relationship is between entities, between me and other person maybe, or one entity is me and my laptop, my computer. That's another entity. And what's the connection between me and that laptop, or me and my class and my lecture? That's the relationship. Another example said here is that a human entity has a relationship with the entity address is live in. So that's the example. I have a home address. That's an entity, and here's me, also an entity of a human. I live somewhere in that home address. That's the exact entity relationship. There are 4 kinds of relationships among entities. The first one is one-to-one. The second one is one-to-many. The third one is many-to-one. And the fourth one, the final one, is many-to-many. And we're going to talk each of them right now. The first one is one-to-one. So we have like 2 entity set, and we can only have relationship. Each of entity are connected to one and one only entity on the other side. So we have here, for example, on the entity A, we have entity 1, and the entity set B, we have entity 1. So 1 and 1 is connected, 2 and 2 is connected, 3 it's not connected to everyone, that's fine, 4 is connected to 3, and that's 1 to 1. If you want to connect entity 3 or entitas 3 here and in this example, and connect it to entitas 2 on the B set, that's not possible because the rule said just one entity and one entity for this A and B connection. For example, about the workers and the ID. So one ID is only attached to one person, and one person will only have one ID. So that's one-to-one. The second one is one-to-many. Here, one entity can attach to several another entity, but on the other side, the one entity, they can only attach to one. So only one to many. Here we say the set A and set B. We say that the set A is the many, and it can be connected to another entity, but all of the entity in set B, there is only one connection between them. So here in set A, entitas 1 and entitas 2 has two connection, two relationship, but in B, each of them only have one. So this is one to many. The many to one, it's the vice versa, or the exact same of one to many, just flip. Yeah. So here we see the entity set in A, there is only one, and the entity set of B, there are some of them, some relationship in their entity. So it's quite simple. One to many and many to one is just the same, but in different direction. Later we'll talk about which one and the connection, the direction of the connection, and that's what going to fill the many to one or one to many. And the last one is many to many. So each entity can have relationship to a lot of entity. For example, here we have set A and set B. Set A in entitas 1 have the connection to entitas 1 and entitas 2 in set B, while set B, entitas 2 in set B have the connection to entitas 1 and entitas 2. That's the connection. The example is like lecture class. So one classroom, for example, the set B is the classroom and the set A is the lecturer. Some lecturer can teach in some classroom, and some classroom can be used by a few lecturer. So that's the connection between those two, many to many. And that is the fourth connection, the fourth relationship. Before we move on, we're going to talk about the key. In databases, we have two types of key. The first one is primary key, and the second one is foreign key. And we're going to talk about it. The first one, primary key. What is that? We're going to step back for a few steps. Each entity must have an attribute that can distinguish between objects with each other. For example, a workers, a human. So here we said manusia 1 and manusia 2. That's human in Bahasa Indonesia. We need to distinguish between these two. And how to distinguish these two human? We need one attribute. For example, in the worker databases, we have workers ID numbers where the rules are just one ID for one human. So each human, each worker in that databases have their own ID. Therefore, the ID can be the primary key. That's the key for each entity to differentiate themselves. So that's the primary key. The second one, we're still going to talk about primary key. Primary key itself may consist of several attributes. For example, ID and gender. That can be a primary key through two separate attributes. However, the combination of these two attributes must be unique, so must be different with another entity in that entity set. So here we see that the most unique attributes of the entity, that's the way to find the primary key. if you can get one attribute which has the most unique attributes, maybe ID or name and gender, for example, and then we can use that as primary key. Here's the example. Suppose there is a candidate key form of the name, NIM. NIM is like the ID number of a student, and date of birth. It needs to be sorted, which is the most unique attribute of these three attributes. We can say that the name is not unique. But in Indonesia, someone with the name Agus is like everywhere. There are lots of people who name Agus. Or maybe in America and Australia, the name John is very common. That's not unique. Similarly, the date of births are also not unique. We only have like 300s of days and millions, billions of people. Here in Indonesia, there's a lot. And around the world, there's also a lot. So the date of birth can be similar. So that is not unique. However, the name or the ID of the student can be an attribute for each entity, because just like the previous example, this is one ID will attach to one person, and this is unique, and this will be chosen as the primary key. Now we're going to talk about the foreign key. We have already seen that the entity in the database must have a relationship with other entities. So in set A and set B, there is a relationship. Therefore, an entity that has a relationship with another entity should load the primary key of the entity that there is a relationship with him. So if you can understand this sentence, so please pause and try to understand it. But if you just grasp a little, and then we can see the example. The example, we have an employee entity that has NIP, or just the ID, as its primary key. This entity has a relationship with the entity with primary key part of the work, the working section ID. So this is the place of that person. To be able to connect these two entities, the employee and the working section, the entity need not to enter the working part of the primary key workers into one of its attributes. So we need to add one attribute to the employee, and those attributes are the primary key of the working section. So the working section's ID. We have this set, the B set, which is the working section. We have attributes of working section ID. Because those are the primary key, if we want to connect these two, the employee table, the employee set, we put these attributes, the working section ID, and put it into the employee set. This primary key that connects between these two, these are the foreign key. So this is the key, but it's from the foreign set of this employee. So this is the one that connects between these two. Therefore, the advantage of using this primary key and this foreign key is that we can access more data. For example, this working section, we don't need to know where it's located, maybe in floor 1, in floor 2, and another attributes over there, but we can just keep the ID, and then the information is stored in the working section set. So we will talk later about that. The basis of the foreign key, there may be one-to-one, there may be many-to-one, and there may be many-to-many. So the relationship is vary. Next, we're going to talk about entity relationship diagram. So the ER diagram is a diagram how we will visualize the connection between each entity set. We have the rules here. There's the rectangles to represent the entity, ellipses that represent the attributes, the rhombus, the line, the double ellipse, ellipse dash, double lines, and double rectangles. You can pause here to read, and then we'll see the example after this. First is that we're going to know that there is two types of entities, which the first one is the strong entity that has a primary key, and the second one is a weak entity that does not have a primary key. Today we're going to talk about the set. So there is these two types of entity. Strong and weak entity will be discussed more in the matter of normalization. So later on the next video we'll talk about that. This is the example. So we have the entity of airplane here and the airport. This entity have their own attributes. So these ellipses are the attributes, and the connection between airplane and airport is this rhombus. The rhombus like a diamond here. So the airplane are based on one airport. And the connection between these two, airplane and airport, is many and to one. Many to one. From airport to airplane, there's one to many. So that's how we read. We can have a relationship between each entity in the same entity set. For example, this airport are neighbors of some airports. So this one is many to many. This one have the connection between these two, the relationship. Airplane type is of some airplane. So one airplane type may be a lot of airplane. For example, Boeing 737. There are lots of Boeing 737. Its type have its own name and its size. So that's the example. And that is the entity. So here we already talked about the entity relationship diagram, how to see this. If you want to explore more, just read it and find the material on the internet. And we already learned about the entity set, the entity itself, the attribute, and the relationship. So that's for today's video. See you on the next video. Goodbye from Computerpedia.